Hi everyone. In the last video, I have showed you where you can download Maxima and how you can install it and how to give the first steps. Today, I want to show you how to deal with the constants, variables, and functions with Maxima. So let's go. We have Maxima open here. I will create a cell called constants. There are two constants that appear a lot in physics that are pi and the Euler constant. And if you want to use these constants in Maxima, we have to type this percent sign and the name of the constant. So in this example, I am using pi. Maxima tries to make the computations the most precise as possible, so it does not approximate the constant by a number. If you want to do so, we have to use a command that is float, and then I can approximate the constant by a number. So, but you have to keep in mind that when you do this, you lose precision. So the other constant that Maxima has defined is the Euler number. And if I use float again, I can see the number. So these are two constants that appear a lot in physics, and we may use it. We may use them sometimes. Let's now see how we can define variables. So, for example, the variables in Maxima, they are defined by this. You type the name of the variable, in this case, the variable A, and you have to type a column to define its value. For example, let's attribute the value of 5 to this variable. And then the variable is defined. And I can use this variable to make operations. For example, I can add a number to the variable, or I can subtract. I can multiply. I can divide it, and so on. We can define other variables, and we can work with two variables in the same operation, or more than two actually. So let's sum A plus B, and let's make the other operations. The product between A and B, and the division. And we can also define a variable using other variables. For example, I can define C, that's the sum between A and B, and I can make operations with C. So this is how we define variables in Maxima. So let me show you now how we can define functions. Maxima has many functions that are predefined, but if the function you want to use is not predefined, then you have to define it like this. For example, let's define the function f, where its variable is x, and let's make this definition. So now I have defined my function. If I want to determine the function in one value of x, for example 3, I can make this. I can define other functions. Let's, for example, define this function g. like this, x squared plus 3 times x minus 2. And then if I want to get its values, for example, when x equals 2, I can do this. We can also define functions that have more than one variable. For example, I can define this. And then I will determine the value of the function when x is pi over 2 and y is 0. And this is the value. So let me give you an example in which you will use variables and functions in physics. So I will give the example of a particle moving in one direction with a constant acceleration. So we are going to define the initial position of the particle, like 1. Let's define the initial speed, minus 1. We have the units here, but since this is a physics situation, but we don't include the units in the values of the variables and functions. So I will not say the units, but it could be meters per second, for example, kilometers per hour, for example, miles per hour. And the acceleration, it's going to be 2. And let's define the position of the particle in function of the time. So this is going to be x0 plus v0 times t plus a times t squared over 2. So this is the function that's going to give the position of the particle in the time. So if I want to determine the position of the particle when the time is 0, then I have this. When the time is 1, I have this. When the time is 2, and so on. So this is an example of what you have seen today. So I hope you have learned how to use constants to define variables and functions in Maxima. If you think this software is interesting for physics or for other areas, please subscribe. See you in the next video.